Hey Brant class, today we are going to look at how to find the area of a triangle. So area, of course, is the space inside a triangle. So let's start with this one here. How much space would be inside this triangle? You know that we measure area in squares. So I see 1 square, 2 squares, 3 whole squares, and I see some half squares. So that's 1/2 square, another half. So 1/2 plus another half would be another whole. So that's 1, 2, 3, 4 wholes, and then another half. So 4 1/2. 4 1/2 square. I think these are centimeters. So I'm going to go with square centimeters. I could just say square units. So 4 1/2. However, you know that you're not going to be able to count the squares every time. For example, if you look here, that might be a little tougher to do because, like, how do you count how much of a square that is? That's not exactly half a square. Maybe some of it is I didn't really draw it perfectly, but that's not exactly half a square, so that's going to be a little trickier. Well, let's go back and look at this one. Now this is a right triangle, and so you may know that this right triangle, this is actually just half of a rectangle. A right triangle is just half of a rectangle. In this case, it's a square because this side is 3 long and that side is 3 long. So actually, this whole square, what's the area of this square? Well, 3 times 3 is 9. There are 9 full squares, and this right triangle is just this square cut in half. So I could just find the square, the area of the square is 9, and cut that in half to get 4 1/2. 4 1/2 is half of 9. Will that work here as well? Let's see. This side is 1, 2, 3, 4, 5. This side is 1, 2, 3, 4. Okay, so this is just half of a rectangle. Just using this for a straight edge here. Yeah, this triangle is just half a rectangle that would be 4 by 5. 4 times 5 is 20, and half of 20 is 10. So this should be 10 square units. Does that only work with right triangles? This here is not a right triangle, but I could make it into a right triangle. In fact, I can make it into 2 right triangles. If I just put a line down here, see how that is a right triangle? And then this one here is also a right triangle. So, this right triangle is just half of this rectangle. And this is 2 wide, and this is 4 here, which is the same. If that side is 4, then this black line I drew must be 4 as well. 4 times 2 is 8, and half of 8 is 4. So this area would be 4. Whoops, let me zoom out so you can see that. 4 square. I don't know what this is here. I'll just say units. I printed this from the internet there. 4 square units. Okay, now this one I'm going to do the same thing. So this is 1, 2, 3, 4, 5, 6 units here. And we already know that this height here is 4. And so this right triangle is half of a rectangle that is 6 by 4. 6 times 4 is 24. So this entire rectangle is 24 square units. So this right triangle would be exactly half of that rectangle. So 24, half of 24 is 12 square units. I'm losing ink here. Uh-oh. So the entire triangle would be 4 square units plus 12 square units. So the entire triangle here is, zoom in again, 4 plus 12, 16 square units. Now wait a minute, because if the triangular space, the shaded space, is 16 square units. See how we really made two rectangles? What if we put this together as one big rectangle? So this big rectangle is 4 high, and 2 plus 6 is 8. 8 wide. What's 4 times 8? Yeah, 32. And the area of the shaded section is 16. 16 is half of 32. So even when you don't have right triangles, you can still just find the area of the rectangle that the triangle would be inside, and then find half of that. So again, I'll write this. 4 times 8 is 32, so that's the area of the entire rectangle. And 32 divided by 2, or finding half of 32, is 16. Another way you could look at it is 1/2 times 32. 32 divided by 2 is the same thing as multiplying 32 by 1/2. So that'll work even if you don't have a right triangle. This brings us to a formula we can use to find the area of any triangle. If we find the base of the triangle, in this case it's 8, right? 6 plus 2, this is 8 long. And then find the height of the triangle. This height is this black line that I've drawn, which is 4. The base of the triangle is 8, the height is 4. 4 times 8 is 32, which gives us the area of the rectangle that would fit around the triangle. Then the triangle is only half of that rectangle, so we cut it in half. So our formula now is 1/2 times the base times the height. That is the formula of a triangle. Multiply the base times the height and cut that in half. This is the same as saying take the base, multiply it by the height, and then divide it by 2. Both of these are the exact same. So let's try that on another one. Here I have the base labeled here. This is 1, 2, 3, 4, 5, 6, 7, 8 units here. And then the height is perpendicular to the base, just like when we found the surface area of parallelograms. So if this is the base, perpendicular would be a right angle all the way up to there. So this would be the height. Here the height is 1, 2, 3 units. So if we put our formula in, the base times the height divided by 2, the base is 8, the height is 3, and then we're just going to divide that by 2. 8 times 3 is 24, divided by 2 would give us 12 square units. Another way to look at this is 1/2 times base times height, so that would be 1/2 times 8 times 3. 8 times 3 is 24, and half of 24 is 12. 12 square units. Let's look at two final examples here. We have this triangle that looks like a nice base here. 1, 2, 3, 4, 5, 6, 7, 8. And here we want to get all the way to that opposite vertex, opposite the base, using a vertical line that is perpendicular to the base. So this would be the height, and that's 3. So again, base times height, 8 times 3, and then divided by 2. Again, this would be another 12 square units. The last example, I have this triangle here. Now what are we going to use for the base? So if we used this for the base, that would be fine, but if we try to make a perpendicular line up to here, it's going to look like that, and it's really difficult for me to see what is the actual height of that. So this would work if I could figure out the actual height of that, but since it's not following one of these actual grid lines, that's going to be really tricky. So in this case, I'd like to turn the triangle this way. Let's see if I can do this. And then make this the base. 1, 2, 3, 4, 5, 6. But in this case, what is the height here? I need a line that's perpendicular to this base. But it needs to go all the way up to this opposite vertex here. So often what you'll see in mathematics diagrams is that they'll like extend a dotted line out here so that they can show a perpendicular line to the base, making the height go all the way up to this opposite vertex. So that would be the height there. So dotted line there, it's usually done outside the triangle as opposed to having the height go here, but it doesn't matter. As long as it's going to this opposite vertex here, you're fine. So in this case, the base is 6 and the height is 3. So let's plug that into our formula. Here we have 1/2 of 6 times 3, or 6 times 3 divided by 2. Remember, these are the same thing. 6 times 3 is 18 in both situations. 18 times 1/2 is the same as 18 divided by 2, which is 9. 9 square units in both situations.